Hello Finxters. Today we're going to be working with times in Python and we'll be using the Python time module. So the topics we're going to cover in this video, we'll revisit the concept of epoch time. We've done this in previous date time and date articles, but we'll revisit again for those of you who aren't that sure. We'll introduce the time module class time structure. And we'll talk about how exactly it is that is structured and how we might use that. We'll talk briefly on the concept of named tuples, and we'll show you an example of that, a very basic example, so you understand the concept. Then we'll introduce a number of functions. That'll be time, time nanosecond, GM time, local time, and make time functions. And then we'll also understand the ctime, StructureTime, and StripTime functions. They will all be explained to you. We'll go through those very shortly and we'll do some coding with them. So, epoch time. Epoch time is a time in seconds from an arbitrary date of 1st January 1970. So from the first second of the 1st of January 1970, epoch time started. And most computer systems use epoch time, and you'll see us returning epoch time very shortly in our coding, and it will just be a long number of seconds for today when I recorded this video, how many seconds since the 1st of January 1970. So the other thing we need to understand for time is the StructureTime class. And it's a Python object and it consists of a time value sequence. And that probably doesn't make a lot of sense to those of you who have not used it before, but it will very shortly. It takes the form of a named tuple. And a named tuple is a subset of the tuple class. It's a tuple with distinct names applied to the values. And so what this allows you to do is, instead of, say, with a tuple of 6 items in it, we would call it by index from 0 through 5. With a named tuple, we can actually apply names to each of those 6 values. And so we can call those values by the attribute or by the name rather than the index. We can still use the index, and we'll show you that too, but it just makes it a lot easier. And we'll be using that with the StructureTime class. So just going quickly through those methods I spoke about in the introduction. Time, very simple. It simply returns the UTC epoch time in seconds. So UTC, for those who haven't come across it, is Coordinated Universal Time, and that is the time at the 0° meridian longitude. Time NS we'll talk about briefly. You should know about it. It's simply the same time as above, but it's in nanoseconds rather than seconds, and you'll see that shortly. GM time, that takes the current epoch time and returns a UTC structured time object. So that's that named tuple format that we were talking about earlier. And we'll show you that, and we'll do some playing around with that to show how easy it is to use. Local time takes epoch time and returns the local structured time object. The MK time, now on this it'll either take a structured time object, or you can actually hand make, if you like, a 9 attribute tuple, and it will, from that, either the structured time object or the tuple that you provided, it will return epoch time. CTime, that takes epoch time and it converts it to a string, and it's a nice readable string, and you can see the format there. So it will return it with the 3 alpha day, the month, the decimal day, and obviously hours, minutes, seconds, and then the year. So it's a nice convenient way of getting a readable time from epoch time. StripTime, that does a string format on a StructureTime instance or tuple, and that allows us to once again put out something a little bit like CTime, but you can actually set it up in whatever way you like using special codes. So you can extract the various pieces from that StructureTime instance, and you can then deliver it in whatever way you see fit, and we will once again do that very shortly. And StripTime does the opposite. it takes a date in string format and turns it into a structured time object. So the opposite of the StructureTime. So enough of that. I would suggest we go and do some coding. So here we are talking about named tuples, just to get started, for those of you who haven't come across them before. So those of you who have, just hum quietly to yourself. So you don't need to do this in the time module, but this is just to explain to you how a named tuple works. So I've imported named tuple method from the collections module, and all I've done there is I've created a named tuple, and I've just put a name in the front and A, B, C, D, and pass that to a variable count. So now, if I want to use that, I can put count in front, open the tuple, A equals 10, B equals 6, C equals 5, D equals 2, pass that to Z. So from now on, if I want to print anything from that tuple, obviously I can index it, and I'll show you that in a second, but it's far easier for me to go print Z C, and that'll return 5. So just showing you that, and there you have it, returns 5. Now, as I say, you can index it just in the same way as you would normally anything else, and that will also return 5. But I quite like the named tuple. It's a very concise and neat and tidy way of doing things. Once you understand that's what a named tuple looks like, it has an attribute and it has a value. When we get on to the structured time syntax, it will make a lot more sense. So let's just jump across now and get back into the time discussion. So to use the time module, obviously import time up the top, and all we're going to do first is introduce you to the time and the time nanosecond functions. And if you remember that time returns epoch time, seconds from the 1st of January 1970, time nanoseconds will return the same time but in nanoseconds. So let's just print that. I'll clear this down the bottom. Print this, and there you see the time return, number of seconds, and the nanoseconds being the second one. So they are epoch time, 1 in seconds, 1 in nanoseconds, since the 1st of January 1970. So that's all pretty simple. So let's move on to, I'm going to comment that out, and I'm going to uncomment these. So let's move on to GM time and local time. Now this is where you'll see your first example of a structured time object. So GM time, as you remember, will take epoch time and it will actually turn it into a structured time object, and local time will take your own local time and turn it into a structured time object. And we'll show that. I've passed GM time to C, local time to D, and down here we're going to print it, and I've just put some names in there so we know which one we're looking at, and we will pass C to it, and let's see what happens. So there you have it, a long tuple. So epoch is structured time tuple in UTC always starts with a time dot structure underscore time and then the tuple, and there you have your attribute time year, and there you have the value 2021, time month 5, time day 21, hours, minutes, seconds, weekday. The weekday starts counting from Monday being 0, and so weekday 4 is Friday today, which is correct. The day of the year 141, and then is daylight saving time, yes or no. and in this case it's no because it's UTC. And similarly down the bottom we have epoch as structure time tuple local, and there you'll see the difference because I'm in London. We are 1 hour ahead because of British summertime, and so whereas it's 4:55 in the afternoon UTC, it's 5:55 in the afternoon here in London. So that's your first introduction to a structure time object, and of course that's immensely powerful, and we will use that shortly to do a few other bits and pieces. So what I'm going to do now is I'm going to comment that out because we're going to get too many things in here, and I'll uncomment this and we'll move on to the next. So we talked about MK time, or I pronounce it make time, and what make time does is it takes that structure time object that we've discussed down here, or it takes a 9-digit tuple which you can create, and it returns epoch time. So whereas we've just created these tuples, we can just as easily take them back to epoch time. So what I've done here is I've decided to take D, which is local time, and that's this one here, and I'm going to pass that to MK time, and that will return epoch time. And then just to show you the 9-digit tuple, I've created a 9-digit tuple in the future, 2022, 3rd month, 15 day, all of these attributes, and you must return, or you must include 9 attributes in the tuple or you will get an error. And we'll pass that to Y, and then we'll once again get MK time to do its magic on Y, and you'll see the outcome of both of those where it will return the epoch time for both of those answers. So let's run that. There you are. So top one is the local time reverted back again. That was the one that we just printed out in structured time long form, and this is the seconds for this date here, 15th of the 3rd 2022. So both very simple ways of doing it, but you just must be sure that you have the 9 values in that tuple if you're going to pass one to make time, otherwise it will error. And then let's just do the last piece of code, and that's using CTime. And CTime is a nice handy function which returns a fairly human readable format, and it will just give it to you in this format, and you see the format there. It'll be day, 3-letter month, the date, time, year. And so we'll carry that out on these 2 epoch times that we have there, and you'll see them return underneath. And there we are, we have Friday, May 21, which is right, and 6 o'clock in the evening, and Tuesday, March 15, 2022, because of course I pulled that tuple forward in time. So CTime, really handy way to get a nice human friendly date format out of an epoch time, which is not so user friendly. Okay, moving on to the last few functions. So the last 2 functions that we spoke about were StructureTime and StripTime. Now StripTime will actually take an epoch time, and here we're going to pass it GM time and local time as we have previously, but this time we'll use StripTime. We'll take GM time and we'll ask it to put out a time which is formatted in that way. Now there's a whole lot of codes you can use for StripTime and StripTime, and you just need to go to python.org and look up the time there, and it will give you these codes. But I'll show you now what it looks like, and then we'll talk through what the codes mean. So there you can see we passed A to that format GMT, and it's returned Friday 21 May 2021 1701 GMT, and we passed local time, which was B, to this format British summertime, and there we have an hour later 1801 British summertime. So obviously %a will give you the 3-digit day, %d will give you the decimal day, %d will give you the month, 3 alpha month, so if it's February it'll be FEB, then obviously year, which gives you the full century year, and then hours, minutes, seconds, and then I just put in the GMT and BST so that we were clear what we were dealing with. So a really useful way, and of course you can put those codes in any format that you like. So if you need a particular format, you just need to go to python.org, look up the time module, and you'll find a large list of all the different codes that you can use to extract just about anything you want from that time, StructureTime class and object. Okay, so let's do it the other way, and let's do strip time. And so what we're going to do here is we're going to comment that out, and strip time, if you remember, takes it back the other way. So effectively what you're saying is you're entering a string. So I've entered the 21st of May on 2021 at 59 minutes past 4 in the afternoon and 34 seconds. And then to allow strip time to understand what that means, I have to show it in code. So %d is the 21, %b is May, so on and so forth. So it can actually put those in the right place. And just show you what that looks like now. So there down the bottom you see the StructureTime object, which has been returned with the information that I gave it. 2021, May 5th, day, 21, 16, etc, etc, etc. Down the back here you've got a -1 on the is daylight saving time, because the strip time function didn't know, and so it put a -1 in, and it does its best to give you the right answer. If you want UTC, you put in 0. If you want anything else, you put in a 1, and but in this case it's -1, so it's telling us that it didn't know the time. And so what it will do, it returns local time. And the beauty of the StructureTime object, as we've discussed before, is we can extract what we want from that. So you notice we're going to print z.timeyear, which is this attribute, and that should return 2021. And we're going to then print z time mday, time mon, and time year, and it will extract the various values from that StructureTime object and selectively print those for us. So let's have a quick look at that. And there you can see 2021 from this one here, and 21/5/2021 from these three here. So once you understand how the name tuple system works and how the StructureTime structures that object with those 9 items, life becomes very easy when you're dealing with time. Okay, let's just head back to the slides. So let's just summarize what we've done here. We discussed the concept of epoch time in Python, seconds from 1st of January 1970. We introduced the time module time structure class and how it's structured, We talked briefly on the concept of named tuples, and we gave an example of that, a simple example, so you understood how they worked. We introduced time, nanosecond, gm time, local time, and make time functions, and also ctime, StructureTime, and StripTime functions. And we showed you examples of each of those functions in use. So we've touched lightly here on most common functions that you'd use in the time module. I really hope that's useful to you, but there's plenty more. If you go to the python.org site and have a look at the time module, there's many more functions in there that you can use. It's an extremely useful module, and I highly recommend you spending some time on it. So thank you very much for watching. I hope it was useful, and I look forward to seeing you in the next video.